Hi, in this video we will talk about Amazon Aurora Serverless V2. It's a scalable compute for your database. Say for example, if you're making use of DBR6G large, which is having 2 vCPUs and 16 GB of RAM, irrespective of its load or irrespective of its usage, irrespective of its load, we pay a certain amount of charges for using that computer. Say for example, 16 GB of memory and 2 vCPUs. Whether the CPU usage is 90% or whether the CPU usage is 20%, we are bound to pay the same fixed amount of memory. How about pay for what you use in the compute side and have the compute scale automatically for you, and that is a possibility with our serverless V2. So it's a scalable compute for your database. It scales automatically when there is a pressure on the CPU side and when there is a pressure on the memory side, or even for that matter network traffic also. You only pay for the compute resources that you utilize on the Aurora Serverless V2. Meaning imagine like on 24-hour period, if you are making use of a certain amount of resources for 23 hours, say for example, if you are only making use of 30% of your resources for 23 hours and just for 1 hour, if you are using 100% of your resources allocated, then for those 23 hours you will be paying precisely 30%. You will be paying only for the 30% of resources, and just for the 1 hour you will be paying for the 100% of resources. Here the capacity, in DBR6G large, you have the specs like 2 vCPUs and 16 GB of memory, whereas the capacity in Aurora Serverless, it's measured in ACU or Aurora Capacity Unit. They only reveal one portion of it. They only say 1 ACU is equivalent to 2 GB of memory, and 1 GB is approximately 1.074 GB, and they mention like corresponding CPU and IO. So basically it would be a shared mission where you are making use of certain amount of resources allocated for you, and here you need to specify what is that minimum ASU and what is the maximum ASU that you intend to use. So when your load is running very low, you will be paying for your minimum ASU usage, and when your load is running at 100%, you will be paying for that highest amount of ASUs that you consume. Say for example, if you are making use of 2 to 8 ASUs, so on a minimum side you will be paying for 2 ASUs, and on a maximum side you will be paying for 8 ASUs. 2 ASUs is 4 GB of memory and corresponding CPU and IO. Similarly, 8 ASUs is 16 GB of memory and corresponding CPU and IO. So this particular thing, Aurora Serverless, is available from different versions on MySQL and also on different versions on PostgreSQL. It's available, as shown in the table, it's available from versions 13.6. They also have a feature of auto pause, meaning when the compute is completely idle and when there are no connections connected to the database, and after a certain configurable idle time limit, the compute can completely go down to the compute can completely halt. That means at that time your database is not making use of any compute, and you will not be billed when the server is in paused state. And when a connection first comes again, when the compute is in paused state, and when a connection comes, the mission automatically comes into the resumed state, and you probably will have to deal with lengthening the amount of time for your connection so that it doesn't go into the timeout and all that issues. So once the mission is resumed, it's available and you can make use of your computer to connect to the database and do all other stuff. So if you want to make use of this feature with minimum ASUs as 0, then you'll have to be on versions 13.15 on Aurora PostgreSQL site and higher. As we all know, with Aurora PostgreSQL, storage and compute instances are disassociated, meaning irrespective of the size of our storage for our database, you can pick and choose a size for our compute instance. Also, Aurora maintains 6 copies of our data in a region to provide high availability for our data. So coming back to our serverless, if you want to make use of 0.5 to 128 ACUs, that is 1 GIB to 256 GIB, will need to be on version 13.6 and higher for Aurora PostgreSQL. And if you want to go down to minimum ACUs as low as 0 and higher ACUs as high as 256 ACUs, that is going to 0 to 512 GIB of memory allocated for your Aurora serverless, you need to be on version 13.15 and higher. You can make use of this serverless V2 for any of your instance types in your regional cluster. In a regional cluster, you can make use of this either for your reader instance or for your writer instance, or a combination. A reader could be provisioned, a writer could be serverless, or vice versa, or both can be even serverless too. You can even make use of this for your Aurora global database side also. Say for example, in a regional cluster with a writer and reader, if you want the reader to be scaling according to the writer's scaling, you can get it by having the promotion tier attribute of the reader either as 0 or 1. If you have the promotion tier attribute of a reader as 0 or 1, its scaling is tightly aligned with the writer's scaling. Whenever the writer scales up, the reader also scales up, and whenever the writer scales down, the reader also scales down. This helps in having a serverless V2 reader instance as a readily available target for your writer instance. And if you don't want the reader instance to be scaling up or scaling down in line with your writer's load, or if you want that a reader instance to be scaling up or scaling down purely on its workload, then that is also possible, and you need to specify the promotion tier as either 2 to 15. In that case, it would scale down basically on the workload of the reader instance itself. In Aurora Serverless V1, scaling is always doubling. That means, from 2 GIB to 4 GIB and 4 GIB to 8 GIB. Vice versa, when you're scaling down, it scales down to half. That means when you're scaling down to 8 GIB, you would scale down to 4 GIB. That's not the case with Aurora Serverless. The scaling would be in smaller increments. They don't reveal the size of the scaling unit. They say it is proportionate to the size of the Serverless V2 instance. Say for example, if you have two instances, one with 0 to 8 ASUs and the other is with 0 to 128 ASUs, the instance with the 128 ASUs, here the scaling unit is bigger when compared with the 0 to 8 ASUs. Also, in Aurora Serverless V2, scaling happens while SQL transactions are in process and while tables are locked and while temporary tables are in use. There is no need for a quiet time for the instance to scale up. Also, whenever a serverless V2 instance scales up or scales down, memory associated with it increases or decreases. This causes certain memory components of the database also to change. In the case of Aurora PostgreSQL, shared buffers, which is used to hold the pages in memory, also resizes according to the scaling. And also certain parameters, you can't really give values to them. Those values will be determined based on the maximum ASU setting that you give for the instance. In the case of Aurora PostgreSQL, based on the maximum ASU value setting, the amount of memory that is available for the auto vacuum process, how many number of workers must be allocated for the auto vacuum process, and this parameter auto vacuum cost limit helps you in controlling the amount of CPU and IO that auto vacuum workers can use, and the maintenance work memory. All these things will be set automatically based on the maximum ASU value that you set for the Aurora Serverless V2 instance. And in the case of MySQL, these parameters are resized dynamically during scaling. Also, the number of connections that are allowed for Aurora Serverless V2 also is a factor of the maximum ASU setting. In the case of Aurora PostgreSQL, from ASUs 32, the maximum number of connections that it can hold is 5,000 connections only. Also, when you change the ASU settings, when you increase the ASU settings, some of the parameters are changed automatically. In the case of PostgreSQL, shared buffers would be resized automatically, but some would need a restart of the instance to be effective. That is, the maximum connections that are allowed. If you change the ASU setting from 8 to 16, the maximum connection changes from 1600 to 3300. For that to be effective, you need to reboot the serverless V2 instance. AWS recommends certain minimum capacity for the minimum ASUs based on the specific features that you intend to use in your serverless V2 instance. If you are planning to make use of performance insights on your serverless V2, AWS asks to maintain at least 2 ASUs as the minimum capacity. And if you are planning to use serverless V2 on a global database, they recommend at least 8 ASUs on the primary side. Aurora Serverless V2 supports SSL or TLS protocol to encrypt communications between the client and serverless V2 DB instances. It supports SSL or TLS versions 1.0, 1.1 and 1.2. And it also supports the below modes for both the MySQL and PostgreSQL side. For PostgreSQL, you can specify you want to connect your connection without the SSL or TLS using disable mode, and with preferred mode you will try to connect with SSL or TLS. If that is not possible, then it will try to make use of non-SSL connection, and you're strictly enforcing SSL using the require mode, enforcing SSL in the require mode, and not only enforcing, it even verifies the certificate authority in the verify CA mode. In the other mode is like, it verifies the certificate authority and also the CA host name. You can specify the cipher suite that you want the client to make use of to have the connection encryption to the database server. So whatever is a possibility in the provisioned instance, they gave the same capabilities as far as SSL or TLS is concerned for both MySQL and PostgreSQL in the Aurora Serverless V2 side. Aurora Serverless V2 also supports different types of logging in both MySQL as well as in PostgreSQL side. In the case of MySQL, you can enable logging for the below items. You can have the general log, and you can enable the slow query log. Once you turn it on, the slow query log, you can specify a time interval beyond which the query is to be logged using the long query time, and you can choose any queries which are not making use of indexes to be logged, and also server audit logging. This is for the advanced auditing, and once you turn on the advanced auditing, you can choose different types of events to be logged: the connections, the database connections and the database disconnections, and DCL, the grant commands or the revoke commands, and the DDL commands, create, alter the commands, or the DML commands. What sort of events to be logged into the audit logging you can specify. And in the case of Aurora PostgreSQL, you can specify to log the connection attempts or log the disconnection attempts or log the statements DDL, DML, what sort of statements to be logged, and log minimum messages, what sort of messages to be logged, error messages, panic messages, fatal messages to be logged in the logs, and log temp files. It logs the usage of the temporary files beyond the specified kilobytes, and log min duration statement logs the SQL queries that were executed beyond a specified time interval. Okay, now we have this provisioned Aurora PostgreSQL instance. The cluster identifier is MIGPRVSVLS, and it is of size DBT3 large. Our intention is to convert this into the Aurora Serverless V2 and also see the metrics related to the Aurora Serverless V2, and also to watch it in the CloudWatch. So I have connected to this database and created a sample schema and a sample table in it, test table. This is a sample data just to induce some load. To convert this into Aurora Serverless V2, there are few options. You can take a snapshot of this and restore the snapshot into the Aurora Serverless V2 instance, or you can just modify the existing instance itself into the Aurora Serverless V2. You can specify the Aurora Serverless V2, and then you can give the minimum ASU and maximum ASUs here. You can see here it does not take 0 ASUs because the existing Aurora PostgreSQL version does not support 0 ASUs. If you see here, it expects 15.7 or higher, whereas my version is 15.4. So I'll have to go with 0.5 at least to convert the existing provisioned instance into serverless. But what I intend to do is to add one more read, which is an Aurora Serverless V2 from 0.5 ASUs to 4 ASUs. Let me add it. I need to give the instance identifier, and then I have chosen serverless V2 and minimum ASU as 0.5 and maximum ASU as 4 ASUs, that is 1 GIB to maximum 8 GIB, and the other settings remain the same. And then I click on add reader. But what I felt about the 0 ASUs is as long as there is any connection connected to the database, the compute really can't go to 0 ASUs, or the compute can't go into the halt state. I basically felt it would be much more beneficial if the idle sessions would get killed after certain configurable time limit, just like in Oracle, so that the compute would go down to 0, and it helps in saving the cost. Because even if I want to make use of this option in the non-prod environment, non-production environments, majority of the developers might not close their sessions. If they don't close the sessions, my ASUs are still consumed and I still have to pay the charges for it. So if we have the sessions exited or terminated based on an ideal time limit, just like in Oracle's profile, that would be more beneficial to use with 0 ASUs. Okay, we are just adding the reader here. Aurora Serverless V2 reader instance is added. You can see here the size as Aurora Serverless V2 and 0.5 to 4 ASUs, and this is a reader instance. We can perform failover and make this as our writer instance. As long as the application teams are making use of the cluster endpoint, they don't have to make any changes because the cluster is always pointing to the writer instance. I have made use of the cluster endpoint here. So let's perform the failover. So now our serverless V2 has become the writer instance. Let me reconnect again. Okay, the same cluster endpoint we are connected to, and now it is pointing to the Aurora Serverless V2 instance. So also our interest to see about the ACU utilization. This metric helps us to monitor our Aurora capacity unit utilization. For certain time I was using 100% of this thing, and when this thing goes down to literally to 0, that's when the compute instance would be going into paused state, and you don't get bill for that time when the compute instance is in paused state. This is one metric for the Aurora Serverless ASU utilization, how much of the ASUs you are utilizing. And there is one more interesting metric, serverless database capacity. Yeah, both of these show what sort of resources you are making use of in your Aurora Serverless V2. Okay, let's go into the Amazon CloudWatch, and this is my cluster instances. This is my provision instance and its metrics, and this is my serverless V2 instance and its metrics. My interest is of to show ASU utilization metric for Aurora Serverless V2. So here if you see for certain time it was closer to 100%, and when the mission or when the serverless V2 was idle, it scaled down, and it scaled down to literally to 10%, and this is the benefit for Aurora Serverless V2. And when the mission was not having much load, it scaled down and it was using less resources. That means I will be billed for only for 10% of my resources, and I have induced some load on my Serverless V2 by running a query. And when the load on the serverless V2 increases, it scales up automatically, and it started consuming more ACUs or more memory, and a corresponding CPU was getting allocated to the machine. If you see here, from 10% it scaled up closer to 80 or 90%, and it got allocated close to 8 GAB for its memory. This is how the Aurora Serverless V2 scales up or scales down automatically, and you will be billed per second billing here. We recommend you to compare the workload of your provision instance and choose a appropriate minimum and maximum ACUs. Also do the cost comparison, compare the cost, like what would be the cost if you switch to Aurora Serverless V2 when compared with the provision instance, and take a call accordingly. And that concludes our video. Thank you for watching.